Let's go ahead and discuss experiment number 3 as what you will be doing. So this experiment, basically you will be observing how the output and of course the closed loop gain of the circuit is going to be changing as you are changing the input frequency. So we discussed about the closed loop bandwidth, we discussed about the slew rate effect in chapter number 4, and we saw that how at different frequencies you can expect different output, and also you saw that what should be the highest frequency that you have to choose for the input sinusoidal signal, such that your output is also linear when you consider the effect of slew rate and closed loop bandwidth. So in this this is a very simple experiment in which basically you have an input signal which is sinusoid, and you will be changing the frequency of that, and you will be observing the output and basically making sense as this output should make sense at this frequency. Again, keeping in mind that the output depends on the frequency, that is the ACL or the gain of the circuit depends upon the frequency. So the first step is you will be making, of course, creating this circuit, and in this circuit you are choosing V input to be a sinusoidal source. So if I go and use V input to be a sinusoidal source right here, and for this sinusoidal source the peak value you are choosing is 50 millivolt V peak, and the frequency, initial frequency for the step number 1 is going to be 1 Hertz. So very small frequency, right, close to DC. So at close to DC, what output do you expect, or what gain do you expect? The gain that you will expect will be simply ACL DC, which in this case is going to be, of course it's an inverting amplifier, so it's going to be negative RF over R1. And since RF is 10, let me go and make sure, RF is 10 kilo ohm and Rn is 1 kilo ohm, so the gain is negative 10. Negative, of course, because the output is 180 degrees out of phase with respect to the input. So at a smaller frequency, 1 Hertz, the output will be 50 millivolt times 10 or 500 millivolt magnitude, right? The peak value will be 500 millivolt, positive peak and negative peak. Okay, next step is that you're going to increase the frequency to the calculated 3 decibel frequency, which is 3 decibel frequency is the same thing as cutoff frequency, break frequency, corner frequency, or closed loop bandwidth. So first you're going to calculate the closed loop bandwidth of this circuit. Now remember, from theory we learned that closed loop bandwidth is unity gain bandwidth over noise gain, and unity gain bandwidth for 741 is 1 megahertz, and noise gain, of course, you're going to calculate for this circuit whatever noise gain value is going to come out to be for this circuit. So you're going to change the frequency of this in the second step to this value. And what do you expect at the output? You expect, since there's a closed loop bandwidth, you expect that the output should be down to 70.7% of the peak value. So 500 millivolt is a peak value of the output at low frequency at DC. So the output should be down to 1 over a square root of 2 times 500 millivolt. And once you see that, basically that confirms that the calculated value VCL is your 3 decibel frequency or closed loop bandwidth. And in the last step, you are going to use the AC sweep function of PSpice, and basically you are going to sweep the frequency to a smaller value to a very high value, and you are going to plot the output. So you're gonna start with, let's say, 1 Hertz like you did earlier, and you go to a very high frequency, I don't know, 10 megahertz, 1 megahertz, right? I don't know, 10 megahertz, let's say, and you will carry out the logarithmic AC sweep. Choose 100 points per decade, that should be good. And when you carry out the simulation, of course, you're gonna see that the output is changing with respect to frequency, and then it's gonna go down to almost 0. The peak value, of course, at 1 megahertz is the one that you observed in step number 1, 500 millivolt. Also observe what will be the value at BCL. Let's say this is BCL, whatever value you will calculate. So the value of BCL should be 1 over square root of 2 times 500 millivolt. That is 70.7% of 500 millivolt, and then of course it's going to go down from there. So these will be the characteristics that you will observe from AC sweep. And that's the experiment. Very simple, very easy. Make sure you have a good discussion. I just want to see that you have good understanding of the AC effect on the operation of these circuits, operational amplifier circuits. Discuss the effect of closed loop bandwidth, discuss also the slew rate, compare your result, expected values, simulated values, and in your lab report, make sure, what I want to see is a systematic way to present your observations. Discussion, anything that you want to discuss should show your understanding, and basically any plot that you have, you need to see if that plot makes sense or not. If it does not make sense, go back and see where you're making the mistake or what can you do. Like I observed in lab number 2 report, there are output is saturated. Now when you see the output is saturated, you should right away, you should say, okay, well, there is something wrong. You should go back and check your input values. But if you don't do that, then I will assume that you don't really have the good understanding of the subject matter. So the purpose of doing the lab is not just to create the circuit simulated, is to understand and confirm your understanding. So make sure you do that and get good points in the lab report.